Hello, it's David. This is my Atari STE. Now, one of the things about these old computers that unfortunately always goes wrong is the power supply. And here it is. Now, Atari, unlike the Amiga machines, has a lovely internal power supply, so you can plug power straight into it, but it does mean that working on the machine when it's exposed is a bit dangerous because that heatsink is at mains voltage. There's a lot of things floating around there at mains voltage, and well, the power supply is roughly 35 years old. So I end up with silly little devices like this 3D printed cap that I pop over the top of it to protect me when working on the system. But wouldn't it be better if I could not need to worry about refurbishing the power supply at all, and not need to worry about killing myself? So what I have here is a brand new, built from scratch, designed from basic principles, power supply unit for the ST and STE. So this is available on the Exxos store, and conversely to the original ST supply, this has got an enormous toroidal transformer on it. There's a much more linear regulation going on in here than the fairly low quality old switching stuff that was happening over there on the ST supply. I mean, this is a switching supply, but the inputs to the switching is all down at low voltage. So this is what you get in the kit. There are some mains wires that we need to solder on, and our output wires are down here. So the idea is that you will be starting from your original supply, and you can reclaim the parts of this that are not included. So, for example, we're going to reuse the power socket, we're going to reuse the switch, and we're going to, we could reuse the plug to the main board, but I've decided I'd like to keep things simple, so I've ordered my own extension, which is also available on the store. These connect in down here, and they have a much shorter path to the main board with this design. Right, so I'm going to start by taking the circuit board off. I've already got a couple of screws out of this power supply because previously I'd mounted my plastic protection device by screwing into it, but took them out for this one. So this should free the actual board proper. There we go. That doesn't look a pretty sight. Right, we need to let's keep those screws somewhere safe. Not sure where somewhere safe is here, to be honest. Put it over there. Right, we need to free up this cable tied bunch of wires. Another one here. So I can leave that earthing strap in place. I won't be changing that earthing one over there. What I will need to do is to get this boot off so that I can desolder from the switch. Does that have to be cut? Is that? There's not a lot of room to work if I leave that in place. Okay. I think maybe the best course of action is to just get desoldering and look at what we have on the new system. So I'm going to turn my soldering iron up a little bit. I normally work at about 290. I'm going to take it up to 330 because these are big old connections here. I don't know how they're going to respond. I'm going to put a dab of my flux on just to see what happens. And let's hold on to the wire there with a pair of pliers, and we'll see if we can get this solder to melt, this 30-something-year-old solder. Well, it's melting, but I can't see what it's doing, so I don't know whether the wire is hooked through, so I might want to try and wick it off. Aha, that looks to me like that's folded. There's a loop in there. There we go. Can you see that? There's that's actually a loop connector. Now that the solder's gone, you can see that, and I suspect the wire is actually just hooked round and wrapped. So I might actually just cut the wire and then tidy up afterwards. So then, same thing with the mains connector over here. Not really. Let's get that boot off now. There we go. Okay, so that's actually the power supply unit liberated. I probably don't need to cut those ones off, did I? That was silly. Silly me. Okay. I think I might need to take that out and clean it and connect those back up. Okay, so there's our crusty looking switch. So I think time for a bit of a clean up on that, and then I will review where these connectors went and reattach them.
Now, whilst I'm doing that, I'll just take a moment to thank the sponsor of this video, PCBWay. PCBWay can provide you with excellent quality boards with a very fast turnaround, but that's not the only string to their bow. They also offer CNC machining, sheet metal fabrication, 3D printing, and injection moulding. So if you're looking to get your circuit boards manufactured, or indeed other projects off the ground, why not have a look at their website? You'll find it linked in the description section of this video.
So after my little faux pas there with the two power leads, I've reconnected those in the correct place. So this is the neutral on the top, this is the live on the bottom, and I've put some heat shrink in there like that, so that should be nice and cozy. So what I now need to do is to introduce the new power supply, and I'm just going to check how she fits initially. I think probably thinking about it, the connector wire to the ST should probably be soldered on before I work on the main side, because I'm just thinking I'll probably work on the main side with it screwed in. I'm not sure. Let me have a think about that. But I'm just going to do a bit of fitting to start with. So it's a little bit of a tight squeeze. Got to get under those cables. There we go. Then once we're under there, okay, I've got. Yeah, I'm not sure that I can get all 4 holes to align at the same time. No, this one's off. So the way this works is because there's slightly different styles of brackets for the ST series, these mounting holes are actually drilled a little bit larger to give you a bit of tolerance, but I think it's probably not even quite enough for my my STE bracket. Yeah, so I can get 3 pretty sure that would work for 3 of them, but yeah, this one down here then wouldn't work. Well, I can go for that one. Yeah, or I can maybe do that one, that one, that one, but then that one there won't work. So, okay, I don't think we're going to be putting all of the screws in, but I only had 2 in anyway, and I think rather balancing one of them wasn't the earth, so I'd done that wrong in the first place. Okay, so that's how that will mount there. The way that these work is that the blue and purple, sorry, the grey and purple for the 240 volt supply should be connected together. So they come pre-soldered together like that. I'm going to put some proper heat shrink over the top. The reason that those are left dangling like that is if you have the 110 volt version, then you need to use those. But I'm going with the 240, 230 version, which requires us to use the brown and the blue. And if years of experience with working on electrical items tells me anything, it's that those are probably backwards. No, that the brown will be the connection to live, so that will go to the bottom half of the switch there, where the black live wire comes in, and the blue will be our neutral, which will go onto there. So that should be a relatively straightforward job. And this I should just try and work out how I want to tuck these ones away. So I think that one's going to come out there, that one's going to come out there, and then because that's got to route back that way. We've got to all fit this in under the case, obviously, so it's a little bit of a tight squeeze in the ST cases. But I think that's probably the best bet, unless that tucks under there maybe and comes back that way. Anyway, we'll sort that out when we get to it. So I think first things first, I'm going to put a lovely old bit of heat shrink tube on there. So the air blower comes out at about 150 degrees. Come to my handy dandy shrink wrap assortment. We'll go for a reasonable sized one. And obviously what we don't want to do is to put the shrink wrap all the way down like that. And then we put a hand on the end and zap, there's 110 volts waiting to get us. So we need to make sure we allow enough clearance at the top there. And in fact, I may even go one further and reapply some insulation tape. So just as a belt and braces approach, I'm going to put insulation tape, and in fact I'm going to put it over the top in that direction, just to stop the end on inadvertent exposure. Slip my heat shrink over the top, make sure that there's a decent amount of space left at the end, and then we'll just introduce the 150 degree C hot air. If you don't have a hot air blower, you can do this with a lighter. It shouldn't catch fire if you stay in the yellow part of the flame, and you see there'll be plenty of people, professionals as well, who will do it with a lighter. Since I have a hot air station, I'm going to use the hot air. There we go. And when you do use a hot air station, remember to remount it and allow the temperature to drop back down before you turn it off, because otherwise you suddenly turn off the airflow. That's the only thing that's cooling it. There you go, it's turned off. Now I can throw the switch. You put it back, you shut it down, it's still hot, the airflow stopped, you can melt and get a mess. So yeah, be careful. Okay, so I think I'm going to turn my attention now to the ST connector. So the idea here is that the reds are 5 volts, the blacks are ground, and the blue is 12. So as my understanding goes, when we look at the Exxos power supply here, the various holes that we've got along here. So these 4 on the left are 5 volts. These 6 with the white tabs between them are ground, and the 2 remaining ones are 12 volts. And of course that lines up really rather well with what we have here. In effect, it is the 6 wires in order that we need to solder. So that should be fairly straightforward. Okay, so first things first, we've got to somehow get the wires into the holes. So we want to solder from this side. So this is the direction. We've got the red to the left and the blue out on its own. And I don't know that there's a better way of doing it than this. Just trying to get 6 cables into a hole simultaneously there. I think that's in. Now how the hell to do this without it all falling out? Yeah, there we go, you see. So we've got them all just about peeking through. I think we're going to need to try and anchor a couple. So I'm just going to put a bit of flux on a couple of them. I'm still set to 330 on my iron. And see if we can just tag them down. There we go. Inelegant, but I think that's good enough. And now we'll do them properly. Nice amount of solder. The demand is normally something like 1.5 amps, I think, for a don't put that one through. Something like 1.5 amps, I think, for the ST, but I think the original power supply is rated up at 3 amps. So with effectively 2 5-volt lines, it's the 5-volt we're talking about here. So effectively with 2 5-volt lines, you know, you're only looking at, for normal operation, say, 3/4 of an amp on each line. So these are more than adequate, and the 12-volt line basically is hardly used. Maybe that requires 125 milliamps or something. I mean, that's plenty, absolute overkill. So mind you, I haven't done that great a job on that one. Back to the switch. Right, so I think how I'll do this is in quite an accommodating way. Actually, I'll push it through like that, and then introduce my solder. Ooh. Oh, I nearly did the oldest mistake in the book, not putting my heat shrink on first. That would have been embarrassing. Okay, so a bit more heat shrink, smaller diameter this time. Cut that down, 1 over my live wire, 1 over my neutral wire. And obviously very important that we do that before we solder it to the switch. Okay, so where was I going with this? Right, so we're going to pop this one in here. Provide a bit of a base for us. Little dab of flux, nice healthy dob of solder, and there we go. Yep, that's poked through the hole and that's flooded to the other side. So I believe that one will be fine. So we'll repeat the process with the neutral. Still aren't completely sure how I want to route this out. I think, to be honest, I'll take the most direct route. We'll worry about the exact folds later on. So this is going to end up sitting this way. So same kind of idea. Pop that into the hole that's there. Apply some pressure in the opposite direction, so that's sitting in a little well. And a job load of solder. There we go. I think we're in. Okay, and I think while we test, I'm just going to push the heat shrink up over the terminals for now, and I'll obviously shrink it down later on. But we need to now try and figure out how we're going to actually mount this into the chassis. So we've got to fold those wires back somewhere. So, yeah, this is a very stiff, and oh yeah. Do I put the switch in first and then try and mount? There's not a lot of room here, is there? Bunching up hard against the fuse there. Maybe for safety's sake, I will actually do the heat shrink now, because we're going to be putting a lot of pressure on those mains wires as we try and mount this, and I think that's maybe then just the safest bet. Okay, so I'm going to remount the switch first, because that did look like that was going to become the hardest thing. So they go on the inside. And the bolts go through into the switch housing itself, which hosts the captive nut side. There we go, we're in. And those do provide connection through to the motherboard ground. So that should be okay. There's grounds on each four corners, so I think 2 is sufficient for the purposes of testing. Yes, what to do with this one? Can I poke that down through there, perhaps? Some kind of wrap around the bottom there. One of the primary design principles of this, why all the switching, all the regulation happens on the low power side. So the big toroidal transformer takes us from 220 down to the working voltage. I don't know what the intermediate voltage is, but I mean, it's low. I guess it's probably around 20 volts. But therefore, the switching occurring over here at such a low voltage, and it is switching, and it is using massive. These things, I can feel the magnetics on that. These things are huge. These could probably do 30 amps, whereas we need 3. So these are the inductors, and this means that these will not saturate. These would be lovely linear that offer lovely linear performance curves all the way across our range. So the wastage, the heat output from the low voltage switching is going to be much lower than it was on the original supply, which was a high voltage switcher. So I'm not too worried about tucking things around like this, because I don't think it's going to get that hot. But there's nothing obviously to tie it to. I might end up just taping it. Yes, I don't know. Suggestions, recommendations. What's the best? What's the best thing to do with the center tap? Okay, so it's time to move on to testing. So amongst my myriad of retro tech here, I have a couple of enormous power resistors. Now these are 25 watt resistors. This one is 12 ohms, and this one over here is 2.2 ohms. I'm not sure that's actually clear on the video. Maybe just about see the printout there. So the idea being is that the 12 ohm one gets connected to the 12 volt rail, blue at the tap, and the 2.2 goes to the 5 volt rail, red at the tap, and they share a common ground which is attached to the chassis here. So when we power this up, cables in here, what we ought to see is about an amp on the 12 volt line and about 2 amps, give or take, on the 5 volt line, which is enough to give it a load such that we can actually test that we're getting the right voltages out before I put it into my machine. Okay, so I'm going to preset the power switch on. Probes in hand, because if this all goes wrong I want to turn it off quickly. And I'm going to connect the power up remotely now. Right, I can hear something happening. Don't hear any bang yet. Right, let's measure from ground to this point. 4.957 volts. To this one should be 12.33. Okay, so we've got good power out. I believe there's a trimmer pot where we can get that up to a 5.05 or 5.1 or whatever our preference is when it's going into the board. But there we go. I don't think we've got any obvious issues there. Okay, so we've got the base board of the STE out. I've put a GoTech in. I've just put my 68K, because the adapter board was already in. I've just put that in. We've got the monitor hooked up over here. So let's add our new caddy. I don't want to drop this, I'll tell you that. I don't want to drop this on the STE. This is a weighty beast. There's a good chunk of metal in there. This should there shouldn't be any worries about heat sinking. Right, so does it fit? This case is a bit tight. I'm not sure why. There we go. We're in. Okay, we're in, and we've got contact. So this is our recently added wire. You see, it's only got to make it down to there. So plenty long enough, no trouble at all. We're set neatly there. Might get the multimeter out so we can do some voltages if this turns on properly. Just pop that here for now. Right, so things to concern ourselves with. We tested the voltage before, it's 4.9. We'll have to measure to see whether that is actually the case, that when we're in situ. There's a little trim pot there, but I'm not sure that's actually the voltage regulator. I'd have to check that. Monitor, I think we're ready. Okay, so this wire is hot. Okay, so we'll carefully put that in there. Right, voltages. Got keyboard. Maybe I'll bring the keyboard just into shot so that we can see the power LED. So the green power LED here will indicate whether we have anything going. All right, and anything else I should check? No. Right, let's go. Throw the switch. Fingers crossed. No explosions. Green light. Nothing on the monitor. Monitor's blank. Let's just check our voltages quickly. 5.025, so that's perfect, but there's nothing on the monitor. Okay, let's turn it off. Right, so what else could we check? Check the floppy. Throwing the switch again. Flash flop is reading okay. Sysinfo picking up okay. I wonder if this is the reset issue. Yes. Oh, wait a minute. Let me just hold reset, release reset. And the monitor is gone green. There we go. Right, we're up. We're up. There we go. Okay, so this is a reset problem, and this is quite common with the slow start, ramp up to try and, as a safety measure to try and reduce, power spikes. The modern power supplies tend to have a soft start. The old reset circuit in these machines doesn't like that, and it's quite a simple modification. Just need to add a capacitor somewhere, I think. But there we go. We're up and running. Let me. Well, I'll just leave that running in the background. Let's have a look at the voltages again. Yep, that's come up okay. It's saying 4 megabytes. So, as expected. Right, so we checked the 5 volts. The 5 volts was good. That's that one. So the 12 volts goes in here. Not sure I'm making a contact there. There we go, 12.3. So that's good. We should be seeing 5 volts here, here. Okay, so I'm going to have a look at this reset fix. Bizarrely, the reset circuit is actually down here, so it's quite accessible for us to have a little look at. Basically, what we've got, there's a 555 timer there. That's U104, I think that's labelled as. So we've got a 555 timer. There's a few resistors, a couple of capacitors, and I mean this one here looks in pretty bad shape to me anyway. And this is the key one. So the quick hack is apparently to add, that's a 10 microfarad. The quick hack is to get a 22 microfarad capacitor and place it across it in parallel. So I've got a little no-name cheapy 22 here, 25 volts 22. That should be okay, I think. Basically parallel that up, and that will give us a sum total of 32 microfarads. So as an initial experiment, before getting the soldering iron out, what I'm going to do is I'm going to put some clips across that cap. So that's on the negative end, the cathode I should say. That's on the anode. And we'll just do it floating in the breeze for now. There we go. So what we've got is this 22 microfarad cap across C100 there. And what we're going to do is to try that again and to see whether that resolves our failing to boot on power up problem. So the trick here is to watch for the green light on the monitor. I'm putting the power supply in now. And I'm throwing the power switch. I can see there's a green light on the keyboard. Green light, there we go. Okay, there we are. That's all it is. That solves the problem. And if I'll just turn that off again. If I now take that capacitor back out of the circuit, just to prove that that was doing something. So I'm going to remove that again. She's gone. Nothing in there now. And we try that same trick. Throwing the switch now, watching for the green light. Green light never comes. Okay, I'll then hold reset for a second. 1, 2, release. Green light. So it's as simple as that. Let's get the soldering iron out. Okay, so I'm going to go for something like this. I will tack down the cathode first down here, and then adjust it a little bit to try and get the anode down there. That's my plan. So much like everything, a little double solder to start us off, a little double flux, sorry, to start us off. I think I might actually switch to using my fingers. I'll try not to get in your way. I'm just going to get a nice big blob of solder on early on. Right, I'm going to try and hold that cathode leg so that it's touching, and then dab in. Try and heat both legs at once. Not sure that's taking. No. Bit more solder. Perhaps not quite enough flux there. No. No, okay, we might need a different approach. I may need to go parallel to it. Let's trim a bit of the leg off. Okay, we'll try and run down so we've got more chance of making contact. Try and go vertically down the leg of the existing capacitor. It's a lot of solder. Okay. Right, might have to do the same trick here then. So get the snips in. Turn the end down a bit. Angle it down towards the board, if you see what I mean. So there's more. Oops, let's see one of it. So there's more chance of making contact. There we go, and we will try the same trick, I think. Big old blob of flux. This time I've got an extra hand. How does that look? I think we're okay. Saw some flux run down the board there. Yeah, I think that capacitor is crusty. Okay, so quick repeat of our test. We're looking for, watching for the green light, remember. I'm throwing the power now. Green light on the keyboard. Green light on the monitor. Another thumbs up. Okay, so the lid's back on, we're buttoned up and we're booting up nicely. And I'm going to enjoy the new cooler power supply and see how I get on. One thing I've already noticed though, which I thought it's worth just showing before I signed off, and it explains why you see that problem with reset. Watch the power light down here. I'm just going to power off. So this is the power light from the keyboard, the one that we had on the side earlier on. But you just watch this when I throw the switch. This, maybe I'm dreaming, I think this comes up slowly. You ready? That fades in, doesn't it? And there you go. That was the problem. That's the issue that you see with the reset circuit there. They're old caps. They were really poorly designed back in the day. They can't cope with that soft start, which you get from a modern power supply, so that you don't send spikes through the system. So that explains that, and all of this information, by the way, is available on the Exxos store. He's got a really excellent series of articles about all sorts of old Atari hardware, and he's in the process of turning it into a wiki. So do keep your eyes on Exxos' website for over the next few months. All this good information is getting archived. It would be such a shame to lose that kind of stuff. But there we go. Another success with our STs. In this case, a brand new power supply, so that hopefully I will not fry or not run the risk of frying the my machines through through age. I can get back to frying them through my own personal brand of incompetence and eccentric additions. Thank you very much for watching, and I'll see you in the next video.